Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is object-oriented programming, and the same chapter, that is the chapter number 7, operator overloading and the type conversion. In the last class we have covered, or we have finished with how to overload the operators or how to use the operator overloading, and in the today's class I'm going to start with the next part, that is this chapter is divided into two parts. One is the operator overloading, one is the type conversion. Now I'm going to take the another part, that is a type conversion part, right? So that is the next part, that is how to convert the file or how to convert the data, that is a type conversion, that is how to convert from one type to the another type, that is from one data type to the another data type. So let's start with the today's session, that is a type conversion, right? So this says we know that when constants and variables of different types are mixed in an expression, that is when different constant and different variables are mixed in an expression or are mixed in a sequence in an instruction, C applies automatic type conversion to the operands as per the certain rules. That is, C uses automatic type conversion, that is automatically the type will be converted, that is a basic to class to basic, or the int to the float, or the float to the double. That is the automatic type conversion to the operands as per the certain rules. Similarly, an assignment operation also causes the automatic type conversion, that is the automatic type conversion is available, that is the assignment operation also causes the automatic, that is available for the assignment type conversion, that is automatically it will assign, that is the assignment type conversion. This type of data to the right of an assignment operator is automatically converted to the type of the variable on the left. That is automatically when we assign the automatic type conversion or automatic assignment, that will cause the data, that will make the data that is assigned the value automatically to the type of the variable on the left. For example, this is the statement that is given. There is one variable that is given, that is a m, then float x equals to 3.14159. So this is a first of all there is a int variable, then there is a float variable that is given as a variable, that is x, that is assigns a value, that is the float value, that is 3.14159. then m equals to x, that is a x is value is assigned to the m, that is x, whatever the x value that is assigned to the m. So that means the float value is assigned to the x. Why? Because this x is the float value, that is in the decimal place. Now it is assigned to the integer values. How is that possible? It will simply show the output as a only 3, not 0.14. Why? Because that is a float part and that is the integer part. So it's better to convert the type, or it's better to convert the one data type into another data type. So this will convert an x to an integer before its value is assigned to the m. So before its value is assigned to the m, first of all it is converted into the integer. Therefore the fractional part is truncated. Truncated means remove of. This type conversions are automatic as long as the data type involved are built-in types. So in built-in data types like int, float, double, there is an automatic type conversion, that is automatically the type will be converted from the float to the int to the float, double to the float, and anything that is available, that is built-in data type, are automatically changed from one form to the another form. Now what happens when they are user defined data types? So for built-in there is available that it is the automatic type conversion whenever there is a execution of the class, execution of the object. But what will be the criteria, or what happens when they are user defined data type? That is, if they are user defined data type, what is the criteria? Consider the following statement that adds two objects and then assigns the result to a third object, that is v1 plus v2 equals to v3. Then v1, v2, v3 are the class type objects, that is the given as the class type objects. When the objects are of same class type, that is when the objects are given as the same class type, the operations of addition and assignment are carried out smoothly and the compiler does not make any complaints. So that is, a comparison is made very easily, and there is no comparison or there is no complaint of the very of the compiler that it is not going smoothly, it is not going perfectly, because everything is perfect, because the every operation, every class type, every object is same of the different class types. We have seen in the case of the class objects that the value of all the data members of the right hand objects are simply copied into the corresponding members of the object on the left hand. So whatever the value that is given, for example, this is the example v1 plus v2. These are also the objects. The addition is compiled, that addition is done, and then it is stored in the v3. That is the addition of the v1 and the v2 is stored in the v3. But if one of the operand is an object and the other is a built-in data type, that is what happens, or what is the criteria when the if one of the operand is an object, that is if we are defining the object v1, v2, v3, and one of the built-in data type that is available, that is the int, char, float. So what will be the result, or what will be the output, or what if they belong to the different classes? That is, if they belong to different classes, for example two objects, and if I want to add them, so how that possible to add the different objects? Then since the user defined data types are designed by us to suit our requirement, because as per my need I will try to become, or I will try to design the class that is a user defined data type, that is how many data members are available, how many member functions are available. So as per my requirement I can adopt any method to build in the data types. Then the compiler does not support automatic type conversion for such data types. So automatic conversion simply applies on the whenever we are using the built-in data type, or whenever we are using the user-defined data type. That is any one data type or any one criteria that is fulfilled, then only it is available for the different data types. We must therefore design the conversions routine by ourselves if such operations are required. And then next paragraph says three types of instructions might arise in the data conversion between uncompatible types. So there are three types of conditions, situation that might arise in the data conversion that becomes uncompatible types. So what are the three situations? That is the conversion from basic type to the class type. So the basic class type or the basic data types are given, like int, can, float, double, that is converted into the class type. Then conversion from class type to the basic type, then conversion from one class type to the another class type. So from basic to the class to the basic, and the one class to the another class type. We shall discuss in detail. That is these are the various conversions that is available in the type conversion, that is from class to basic, basic to class, and the one class to the another class type. So first one is basic to class type, that is the first part. The conversion from basic type to the class type is easy to accomplish, that is it is easy to accomplish, it is easy to use, that is how to convert the basic type to the class type. It may be recalled that the use of constructors was illustrated in a number of examples to initialize the objects. For example, a constructor will be used to build a vector object from an int array object. Similarly, we use another constructor to build a string type object from a char pointer type variable. These are the examples where constructors perform a de facto type conversion from the argument type to the construction class type. So there are so many examples whenever we define the int array, whenever we define the char pointer array. So in this cases the conversions become difficult, or conversions become one of the biggest challenge that is available in the different data conversions. Now consider the following constructor. This is the example that is given. The name of the constructor is string, as well as the name of the constructor is string. That is the name of the class, and string are the equal. And with this in parentheses there is a given, that is a char pointer a. That is a is given as a pointer variable that points to the character value, or that stores the character value. Then there is a length that is calculating the length, that is a strlen a. That means the length of the string will be calculated. What type of string? That is available in a, and the length will be calculated by using the formula. Then p equals to new char length plus 1, that is a space will be allocated, or space will be occupied, space will be taken for the new character that is to be permitted, and there is a argument that is a length plus 1. Then strcpy, that is copy the string from the p to the from a to the p, that is a p comma a. Then the string will be closed, or the definition of the constructor will be closed. This constructor builds a string type object from the char type variable a. The variable's length and the p are data members of the class string. Once this constructor has been defined in the string class, it can be used for conversions from char pointer type to the string type. So this can be used for making the conversion from the char pointer to the string type whenever we declare the object or whenever we use the objects. So this is given an example, that is a string is the name of the class, s1 and s2 are the two objects. Then there is a char pointer name1, that is the name of the name1 is the name of the character, name of the pointer that is used, that is of character type. That is a char pointer name1 equals to IBM PC, that is the name of the string 1, name of the char pointer 1, name of the pointer variable. So it can be used for the conversion from char pointer to this one. These are the two objects that is declared. Then there is a char pointer name1 equals to IBM PC. In the same way, char pointer name2 equals to Apple computer. So these are the two strings that is given. Then finding the string from the name1, that is the finding the substring from the name1, that is the s2 equals to s1 plus, or s1 equals to string. Then there is a name, that is whatever we give in the name, that is occupied or that is performed or that is used. So there are two pointers that is used, that is name1 and the name2. Then s1 equals to string name1, s2 equals to name2, right? Now the statement s1 equals to string name, that is the second last point, that first of all converts the name to the char pointer. That is, first of all, the name1 will be converted into the char pointer type to the string type, and then assigns the string type values to the object s1. That is, assign the value of x to the, or assigning the value of anything to the, or the output of the this one is transferred to the object s1. Therefore, the statement like this one, s2 equals to name1, also join the same job by invoking the constructor implicitly. Now let us consider the same example, or the another example of converting an int type to the class type. This is the example that also includes the same job by invoking the constructor implicitly. Now let us consider the another example. This is the class that is declared, that is of time, and there are two data members that is available, that are the hours and the minutes, that is the HRS and the minutes, that is MINS. Then public, there is two blank data lines or the data member that is available, and then there is a time in t, that is a constructor has also been defined, that is the time t d, or time int d. Then there is a curly braces start, then r equals to t by 60. So whatever the value that is given in the t, that is a time, it is divided by the 60, so it gives the timing in the program. In the same way, there is a minutes calculation, that is a t modulus 20. So these are the two string, or these are the two variables that is declared, that is perform the operation, that is inline function that is available in the class time. Then there is a closing of the class, that is a closing of this one class, and there is a semicolon that is available. The following conversion statement can be used in a fraction, that is the object, that is a time t1 time distribution, or int distribution, and then ti equals to duration, not distribution, it's duration. So one object can be created, that is a t1, Then the into the class type, that is the int variable, is divided into the class type. After this conversion, the HRS manager of T1 will contain a value of 1, and the means member of a value of 25 denotes 1 hours and 25 minutes. The constructor that is used for the type conversion takes a single argument whose type is to be converted. Next is class to basic data type. So in this we have studied how to change or how to convert or how to now how to convert the class into the basic, right? The constructor did a fine job in the type conversion from the basic to the type. So till now we have covered how to convert from the basic type to the class type. So the next conversion is class to the basic type. That is how the one class is converted into the basic type, that is the int, char, float. So the constructors did a fine job in the conversion from the basic to the type. So till now we have studied that how the constructors are used to convert from the basic type to the class types. What about the conversions from a class to the basic? That is, what is the criteria to convert the data or convert the type from the class to the basic type? The constructor function do not support this operation. So if a question arises in a assignment that constructor is used to convert the data from the basic to the class, yes or no? So that is a yes. But constructors are used to convert the data from the class to the basic, that is not correct, right? Luckily, C++ allows us to define an overloaded casting operator that could be used to convert a class type to the basic type. The general form of an overloaded casting operator function usually refers to an conversion function. So how to overload or how to use, it uses the casting operator that is used to convert the class type to the basic type. That is the overloading of the casting operators. Then how it define, that is how to convert the class type to the basic type, that is how to define or how to convert. So this is the syntax that is used, that is operator type name, that is the operator is a keyword and the type name is the name of the function that is used. Then there is a curly braces, and then there is a function statement. So these are the function statement that is available. So this is the operator, that is a keyword, this is the type name, that is the name of the type, that is either int, char, float, or any class name that is given. This function converts a class type conversion or a class type data to the type name. For example, the operator double that converts a class object to the type double. The operator int converts a class type to the or class type object to the type int, and so on. So consider the following conversion that is available. That is a vector, then there is a scope resolution operator, then there is a operator, then there is a double. Then double sum equals to 0, that is in double the variable is defined as a sum, that is the sum equals to 0. Then there is a for loop that is available, that is int I equals to 0, I is less than size I plus plus. Then sum equals to sum plus vi plus vi. Then return square root of sum. So this is used, that is, or this defines how the it will be used. So the operator is a vector. Then there is a the name of the class is the vector, and there is a operator keyword that is used, and what is the type of the object, type of the data, that is a double, right? Then uses the double sum equals to 0, that is define the variable sum as a 0. Then for loop will be used, that is taken the values as a 0, that is the initial value of I as 0, that is going to the size. Then there is a I minus minus. Then there is a sum variable that is used to store the output, that is sum plus vi plus vi, or sum plus vi into vi. Then return square root sum. Then there is a closing of the vector function. This function converts a vector to the corresponding scalar magnitude. That is this function that is used that converts a vector to the corresponding scalar magnitude. Recall that the magnitude of a vector is given by the square root of the sum of the squares of its components. The operator double can be used. So what is the uses of double operator that can be used? Double length equals to double vi. That is the length of the name of the variable is length, and double vi. That is the vi is the operator that is used. Then double length equals to v1. That is the v1 is or length is assigned the value, or v1 value is assigned to the length variable. So either we can use this one, that is before length variable and before v1 variable there is a double keyword that is used, and this is also correct, that is the v1 is assigned to the length, where v1 is an object of the type vector. So v1 is, what is v1? That is an object of the type vector. Both the statements have exactly the same effect. That is, both the statements have the same effect, same meaning, everything is same. When the compiler encounters a statement that requires a conversion of a class type to the basic type, it quietly calls the casting operator function to do the so. So whenever the compiler encounters a function or encounters a statement, that is a statement that is given, that is used to convert the class type to the basic class type, it uses the casting operator function to do the so. That is, it uses the casting operator function or the casting function that is used to perform the task. The casting operator function should satisfy the following conditions. That is, the casting operator must satisfy the conditions that whenever we use the casting operator, so these are the various conditions that is must be satisfied to use the casting operators. What are the various conditions? The first condition is that it must be a class member. That is, the casting operator, whatever the casting operator we are using, that must be a member of the class, that must be a part of the class. Then it must not specify a return type. That is, there is no specification of the return type. That for example, we are taking one example that also shows the return type. That is not possible in the operator function. Then it must not have any argument. That is, there is no argument in the operator functions. Since it's a member function, it is invoked by the object, and therefore the values and the type conversion inside the function belong to the object that invoked the function. That is, the function do not need any argument. This is the example that is given in the string example discussed in the previous section. We can do the conversion from the string to the char. So we have taken one example, that is conversion. Now let's see how it is used to define the or to convert the character from the string to the char or string to the int. That is conversion from the string to the char pointer. Now there is a string, that is a class name, there is an operator, that is a keyword, then there is a char pointer, then there is a function, that is a char pointer means the char pointer will be used, then there is a return p, that is a p will be returned, that is a return p. Then the next one is, or the next type of conversion is one class to another class type. So we have discussed till now from the class to the basic, from the basic to the class, from the class to the basic, it is available in the form of the without using the constructor like this one. This is the class to the basic without using constructor but using the casting operators, and from basic to the class we are using the constructors. Now third one is from one class to the another class, that is how to convert or how to initialize, how to assign the value from one class to the another class type. So we have just seen data conversion techniques from a basic to the class and the class to the basic type. But there are situations where we would like to convert one class type to the another class type. There are some scenarios in which we want to convert from the one class type that is available to the another class type. For example, this is the example. These are the two objects of different classes. So object y is assigned to the object x. That is, object x contains the object y value. So object x is an object of the class x, and the object y is an object of class y. As I discussed, that these are the various objects of different classes. The class y type data is converted to the class x type. That is the class y type that is available, that is converted into the class x type data, and the converted value is assigned to the object x. Since the conversion takes place from the object class y to the class x, that is, every conversion takes place from the object y or the class y to the class x, y is known as the source class. because whatever the or where the data is put in or where the data is stored, that is known as the destination, and from where the data is fetched up, that is known as the source. So y is known as the source class and x is known as the destination class, right? Why? Because y is going to the x. Now object x contains the value, whatever the value that is given by the object y. Such conversion between objects of different classes can be carried out by either a constructor or conversion function. So we may use any criteria for converting the objects from one part to another, for converting the object of different classes, that is carried out by either constructor or a conversion functions. The compiler treats them on the same way. Therefore, how do we decide from which form to use? That is, which form to use, either from the conversion of different classes to one class, from different rules to another class, or which will be defined. So it depends on what we want the type conversion function. That is, where we want to put the type conversion function, that is to be located in the source class or in the destination class. So we know that the casting operator function, that is used in the last term, that is from the um, class to the basic example. So we know that the casting operator function, that is operator, then there is a type name, then converts a class object of which it is a member of type name, sorry. The type name may be the built-in data type or user defined, that is available, and any data type that is available, that is a type of the name, that is either int, either class, either union, any data type that is given, either may be a user defined, either may be a predefined, that is a built-in data type. In the case of conversion between objects, type name refers to the destination class. So whenever there is a conversion between the objects, the type name will be or refers to the destination of the class, that is from where or to which the class belongs. Therefore, when a class needs to be converted, a casting operator function can be used. So whenever there is a need or whenever a class needs to be converted, a casting operator function can be used, that is known as the class object or the source class. The conversion takes place in the source data or the source class, and the result is given to the destination class object. Now consider a single argument constructor function which serves as an instruction for converting the argument type to the class type of which it has a member. That is, consider a single argument constructor function that is used for converting the argument type or taking the class type for which it is a member. This implies that the argument belonging to the source class and is passed to the destination class for conversion. That is, the argument is given from the or taken from the or belongs to the source class, and it is given to the or it is passed to the destination class for the conversion. That makes or this makes it necessary that the conversion constructor be placed in the destination class. That is, a conversion constructor means how to construct or how to convert the constructor that is placed in the destination class. Figure 7.2 illustrates these two approaches, that is how it is used. Now object y is converted or object y is divided into or converted into object x, that is a converted value of the type x. Then class y, that is using the casting operator, the function, that is a conversion here, that is a conversion is given, that is a source class. So class y, that is a source class that is available, this is the class y. Then data access function, that is how to access the data, that is the data access functions. Then converted values of type x, that is given or that is stored as a converted value that is stored in the object x. So in simple terms, whenever we want to convert from one class to another class, so one makes the destination class, one makes the source class. So one object of one class are considering or are converted into object of another class. This is the class x constructor function, that is conversion here, that's the destination class. Table 7.3 provides a summary of all the three conversions. That is, this is a table that provides the summary how these will be converted. It shows that the conversion from a class to any other type should make use of a casting operator in the source class. On the other hand, to perform the conversion from any other class type to a class type, that is if I want to perform any class type to the another class type, that is a constructor will be used, that is constructor should be used in the destination class. Now this is the type conversion table that is used from the basic to the class that is given, that is not applicable, then there is a constructor. Then class to the basic, that is a source class, that is a casting operator is used, and there is no foundation or there is no rule that is applicable to the destination class. And whenever there is a conversion from class to class, the casting operator is used in the source class and the constructor is used in the destination class. So this is a figure that shows the overall conversion how the overall conversion can takes place. That is the source class and the destination class. When a conversion using a constructor is performed in the destination class, we must be able to access the data members of the object that is sent by the source class as an argument. So whenever a conversion is made using a constructor that is placed, that is performed in the destination class, we cannot be or we must be able to access the data members of the object that is sent as an argument. Since data members of the source class are private, since the class of the data members are available as a private, we must use special access functions in the source class to facilitate its data flow to the destination class. That is also available, that is to make the class as a private, it is also accessible to access the data members of the class. This is an example of the data conversion, that is how the data will be converted. And this is also the ending of the chapter. After this we will be taking the practical approach. So let's see in a hurry way, that is how to convert the data. So let us consider an example of inventory to a product in a store. So this is an example that is used to take the example of an inventory of the product, that is the stock of the product in the store, that is how much stock is available in the store. One way of recording the details of the product is to record their code number, total items in the store, and the cost of each item. So one of the way that is available is to record the code number, that is what is the code number, how many total items are available in the store, and the cost of each item. So first of all, each code number that is given to the inventory, then what are the total items that is available in the inventory that is in the store, then the total cost of each item, that is what is the total cost that is available for each item. So this is one of the way that is available to record the code number, total items, and the cost of each item. Then another approach is to just specify the item code and the value of the item in the store. So this is another approach that is used, that is just referring or that is just specifying the item code and the value of the item that is available in the stock. The example that is shown in 7.5 uses two classes and shows how to convert data of one type to the another class. So this is the example that shows the same example of the inventory, that is how to take the inventory, how to use the inventory, and how to rotate the inventory, and how to apply the cost to the various item, total item in the stock, or the cash will be used. Now this is an example that is given. Now let's see what is the example. That is a hash include iostream.h, then using namespace std that is given, then class invent2. So first of all, the destination class will be declared, that is the destination class declared, that is the destination class that is used. Then class invent1, that is the source class that is used. So there are two classes that is used. One is the inventory2, that is a destination class. One is the inventory1, that is a source class. Then this class will be defined in this, that is a int code, that is a code number, that is a item code, items, that is a number of items, and the cost of each item. So there are three data members that is available. One is the item code, one is the number of items, and one is the cost of each item. Then there is a member function that is available. One member function is invent1, that is a public part, and there are three argument that is used, that is a int a, int b, and the float c. Then there are three values that is passed. Then a is assigned, or a is given in the code, that is code has taken the value of a. Then b values is given to the items, and the c value is given to the price. Then void put data, that is a put data function is also used. Then see out code equals to, that is a code, that is a code that is display as it is, that is a code equals to, then the code item, that is the a value will be printed. Then items equals to, that is the items will be printed. Then value equals to, that is the price will be printed. So these are the three terms that is used. One is the code, one is the items, one is the value. In code there is a value, in item there is a b value, in value there is a value of the price, that is a c value. So this is one of the member function, invent one, that is the inventory one. This is another member function, that is a put data. Right. Then int get code, that is a get code is also a member function that is given. Then there is a return code. Then int get items, that is getting the items. So first of all, the function is get code, that is getting the code. Then getting the items, and the explanation or the definition is simply returns the code, simply returns the items. Then float get price, that is getting the price that is available. Then simply returns the price, that is how to get the price, or how to simply return the price. Then operator is used so that to convert the class into the class type, or the class to the basic type. Then operator float return items into price. This is one of the important. This operator is a keyword. Float is the basically the data type. Then return, how to return, that is items into the price. Then this is operator invent to, that is from invent to the invent one into the invent two. Then invent to temp, that is a to invent to data type is converted or become the data type, and the temp variable has been defined. Then temp dot code, that is taken the value of code and it is stored in the temp dot code. In the same way, taken the price into the items and store the values in the temp dot value. Then there is a return temp. So this is the operator invent to, that is a invent to will be used. And then there is a closing of the class, and there is a semicolon, that is a terminated of the source class. So in this we have defined, we have declared first of all one class, that is a invent2. Then define one class in which there are different member functions and there are different data members. So data members are code, items, price, and the member functions are invent1 and the put data, get code. These are the various member functions, right? This is the operator that is used to convert the data type, one data type into the another data type. Now this is a destination class, that is the next class that is defined. Again there are two data members, that is a code, that is of int, and the value, that is a float. Then there is a public part, that is a definition of the member functions. Then invent2, then code equals to 0, value equals to 0, that is 0 is assigned to the code and 0 is assigned to the value. Then invent2, then there are two data members, the argument that is used, that is the int x and the float y, that is the constructor for the initialization. Then code equals to x and the value equals to y, that is x is given to the code and the y is given to the value, that is the value is assigned the y value, and the code is assigned the x value, that is the invent2. Then there is a put data, that is a void put data. Then see out code equals to, that is it will be printed as it is, the code value or the code will be printed. Then value, that is a value will be printed. Then there is a invent2, invent1 p, that is a constructor that is used for the conversion. Then code equals to p dot get code, that is the get code is a function that is called. Then value equals to p dot get items, that is and the p dot get price, that is both are multiplied with each other, get the get items and the get price, that is the end of the destination class. And then there is a closing curly braces and there will be a semicolon. Then int main, that is the main function is used. Then there is a invent1. Now this is the declaration of the objects. What is the name of the object? First of all, that is the s1, and there are multiple values that is assigned in the s1. What are the values that is given? That is the 100, 5, 140.0. Then invent2 d1. The object of the invent1 is s1, that is also assigned the values, and the object of invent2 is d1, that is also given the values, not assigned the value. Then float total value, that is assigning the invent1 to the float, that is the total value equals to s1. Then invent1 into the invent2, that is a conversion from one class to the another class, that is a d1 equals to s1. Then cout product detail. What are the product detail? That is getting the data from the get put data. So this is the detail that is given, that is display the values. Then cout, what is the stock value? Then value as it is printed. Then there is a total value. Then product details d1 dot put data. So first of all s1 dot put data, then d1 dot put data. This is the output that is given. First of all, product details, inventory one type. What is the code? That is 100, then 5, then 140, then stock value is 700. How is that possible? This is 1. That is 100, 5, 140, then stock value is 700. How is that possible? Because this is the formula that is used. First of all, the get items, then into the get price. This is also a formula that is used, that is the price into the items. So this is what 140 into 5, that is your 600, then 600 plus 100 is 700. So this is a code plus items into value, that is the value equals to 700. Then next is the invent2 type. What is the code? That is 100. What is the value? That is a 700, because everything is same, every data is same, every invent same, that is every member is same. So that is the invent2. And now we have used the conversion functions, operator float, there is a parenthesis. So we have used the conversion function, that is a casting operator that is used, that is the operator 1 in the class invent to convert the invent1 type into the float. So this will be used to convert into the float, that is converting the int data type or the invent1 class to the float, that is from the basic to the, or from class to the basic, that is using the first, that is using the casting operator, right? Then invent2 invent1, that is used to convert the one class into the another class. So this is used to convert the invent into the invent1. Then remember that we can also use the casting operator function, that is operator invent2, that is also used to convert the class into the operator or class to the another class. However, it is important that we do not use both the constructor and the casting operator for the same type conversion. That is, we do not use, or we are not able to use both the constructor and the casting operators for the same type conversions, since this introduces an ambiguity. So whenever there is a int or whenever there is a float, so there is no advisable to use the casting operator as well as the constructors at the same time, because it produces an ambiguity as to how the conversion should be performed. Now summary. What is a summary? First point says operator overloading is one of the striking feature that is available in C++. So we are finished with the chapter. Now let's take what we have covered in this chapter. The first point says operator overloading is one of the important striking feature, or one of the important feature that is available in the C++ language. Yeah, that is correct. That is operator overloading is one of the striking feature that is part of the C++ language. It is also known as compile time polymorphism, because this polymorphism, this operator overloading is performed at the compile time. So it is also known as the compile time polymorphism. Then using overloading features, we can add two user defined data types such as object with the same syntax just as the basic data types. We have studied that we have defined, or we can define the user defined data types such as the object with the same syntax just as using the basic data types. Then we can overload almost all the C++ operators, but there are some exceptions. The 4 operators cannot be overloaded. What are the 4 operators? One is the class member access operator, one is the scope resolution operator, One is a size of operator, one is a conditional operator. Then next point says operator overloading is done. That is, we are using the operator overloading with the use of a special functions that are known as operator functions, which describe the special task to an operator. Then there are certain restrictions and limitations in overloading the operator. There are some foundations, there are some limitations that is used in overloading the operators. Operator functions must either be a member function or a friend function. The overloading operator must have at least one operand that is of user-defined type. That is, the overloading operator that is used, that must be of same operand that is of user-defined type, that is used as a member function or a friend function. The compiler does not support automatic type conversion for the user-defined data types. We can use casting operator functions to achieve them. The next point says the casting operator function should satisfy the following condition. So the casting operator function that is used should satisfy the following conditions, or the what are the various conditions that is used with the casting operator whenever we want to convert from one type to the another type. So what are the various conditions that must be satisfied? First of all, it must be a class member. That is, it must be a category of the class members. Then it must not specify a return type. That is, there is no return type, or there is no return type of the casting operator function. That next, it must not have any argument. There is no argument in the casting operators. These are the various key terms. These are the various question answers. So we are finished with this chapter, that is the chapter number 7, that is the operator overloading and the type conversions. These are the various questions that is available. These are the debugging exercises. Now next is these are the exercises that is given. Chapter number 8, that is the inheritance. This is one of the important as well as the easiest topic, easiest chapter. But before I'm not going to start right now, but first of all, let's take a break only for 10 minutes max to max. I'm sorry. So let's take a break right now, then move to the practical part after the break. Then in the tomorrow's class I will be starting your next topic, that is the inheritance. So let's take a break right now. So come back from the break. Now let's start the session again with the practical approach. So now let's see the practical approach of the classes. In the last class we have discussed one friend function class. Now I'm going to continue with the class function, that is how to return the object in a classes, how to return the various object. Remember, we have considered or we have studied one example of the complex number. The same example will be carried out, that is, a function cannot only receive the object but I can also return the value. That is, there is the option to return the objects. Now let's see how to return the objects. So first of all, hash include same as iostream.h, right. Then there is a hash include, that is a conio.h, that is the same header file will be used. Then there is a class complex that is given. Then there is a curly braces open. Then there is a float x and the float y. Then use the public. So these are the two private members. Then use the member functions or define the member functions in the public part. For example, if I'm taking one as an input, that becomes the inline function for taking the input, that is float real, float imaginary, right. Then this will be assigns the value of real, and y is assigns the value of float or imaginary. Then there is a closing of the curly braces. Then uses another function, that is a friend function. because it is defined in both the classes, that is a friend complex, then there is a sum, then there is a complex. Right, so these are the two arguments that is given. Then there is a closing curly braces. Then there is a it is only defined, so we are using, or we have to use the semicolon over here because it is only declared, not defined. Then void show complex, this is also defined. Then void show complex, then there is a closing, then this is the opening, then there is a semicolon, right? Then this class will be closed over here, then there is a semicolon. Then the new, that is a definition of the friend function, that is a complex sum, then there is a complex, for example C1, then complex, that is C2, for example. These are the various argument that is used. Then again there is a parenthesis because this is as it is will be written, that complex sum, complex, so this is complex C1, complex C2. Now one object will be declared of the class, that is a complex C3, for example, because the output will be stored somewhere. So this is C3, then C3 dot x equals to C1 dot x, then plus C3 or C2 dot x, yeah, this is correct, then C2 dot x, then there is a semicolon that is used, right? Then in the same way, C3 dot y, here there are two values, that is a float and the real, that is the x and the y, equals to C1 dot y plus C2 dot y. Then again there is a semicolon, then there is a return C3, then there is a semicolon. So this will return the object as a C3. Then this will be given. Now there is a show function that is left for giving the definition. So this is used as a void, then complex, then there is a scope resolution operator, then there is a show, then there is a complex C, then it is used, or it is given as this one, then C out, then C dot x, then plus J will be written as it is, then this is over here, then C dot y, then written over here, then there is a slash n, then there is a semicolon, that is simply printed the x C dot y x value and the C dot y value. Then there is a closing, then there is a int main, that is a main function will be used, that is a int main. So this is the bottom up approach, starting with the int main function. So it returns a 0, then there is a curly braces, then there is a complex, then A, B, C. These are the three objects that is given, that is used to take the values. That's why given in the capital letter, that is A dot input, then three values will be given, or two values will be given, that is for the x and the y. One is a real, one is a imaginary, both are of float value, so we can use any value for this one. So this is 3.51, then comma, then there is a 5.5, for example. This is one of the example. Then B dot input, that is a B dot input, then there is a 2.7, and then there is a 1.2, right? Then there is a C equals to, then there is a sum, then A comma B, that is the addition of the sum, then C out, that is in the double quotes, A equals to then it is given as a dot show, that is a show function will be called over here. In parenthesis it is also showing over here. Then C out, that is B equals to, then B dot show, then C out, C equals to, then C dot show, then there is a return 0, then there is a get C, no, get CH is written over here, then there is a get CH, then this is the closing. Now if I compile this code, there are 4 errors. Statement missing. Where is the statement missing? That is the statement missing over here. There is no semicolon over here. Semicolon, and then there is a semicolon. Now if I compile this code, again there are 4 errors. Undefined symbol C. So this is not defined because this is in a small letters. Now if I beg, now there are 3 errors. Illegal structure statement. That is, this is illegal because this is not showing in the one line, that is only showing in the next line. So if I use this one, then use C out, again this one. Now if I compile, again there are 3 errors. Illegal structure operation, that is 37, that is this one, that is a dot show. So this is the part of this one. Now if I use only this one like this, now let's see, there are 2 errors. Yeah, that error will be removed. So instead of this there is a semicolon because it is used in only 2 or 3 lines. Now if I compile, there is no error. If I execute, this will be printed like this one. So this is these are the 3 complex number that is given, that is 3.1, 5.5, 2.7, 1.2. Now this is the addition, that is C is the addition of the C1.x and the C2.y. That is 3 plus 2 is 5, 7 plus 1 is 8, so that is 5.8, and then there is a 5 plus 1 is 6, and the 5 plus 2 is 7. So this is given as a 5.8 plus j, 6.7. How this j will become? Because we have already introduced the j, that is a plus j in the double quotes to utilize this one, right? So now if I want to use the clear screen, that is CLR SCR for clearing the screen. Now again if I compile, so this is only one screen that is given. Now if I change the values from this one to 2.5, and over here 4.5, and over here this is 3, this is for example 2, and this is 9, and this is for example 9, this is 9.9. Now if I execute this code, this will be printed in this form, that is 2.5 plus 9.9, that is 12.4, and 4.5 plus 2.3, that is a 6.8. So this is the value that is given, that is if the values goes beyond the 10, that is also showing as 11, 12, any value that is given. This is A, B and C. Alright, so these are the various complex number that is used. So let's see what is the program, or what is the content that is available in the program. So first of all, 2 header files are used, that is the hash include iostream.h, then hash include conio.h. So these are the 2 header files that is used, that is the iostream and the conio. Then there is a class complex, that is a complex is the name of the class. and there are two data member, that is of private part, that is the x and the y, that is the float x and the float y. Then there is a public, that is in a public part it is defined as a member function, that is a void input. So input is the name of the we can say member function that is used, and the return type is void. So that is a void input. Then there is a float real, float imaginary. So there are two parts, one is a real part, one is the imaginary part. So the two parts are given, one is a real, one is the imaginary, both are of float part. Then assigns the value of real to the x, that is x is given the value as a real part, and imaginary value is given to the assigned to the y. Then there is a friend function that is used, that is a friend complex sum complex complex. Then void show complex, that is also given. So this is a friend function that is first of all uses by using the keyword that is a friend, then complex sum complex complex. So these are the two arguments that is given, that is a complex sum sum or complex sum complex complex. So these are the two arguments that is given. So this is one of the friend function that is used. So this is a friend keyword that is used. Then there is a complex, that is the name of the class. Then there is a sum, then complex complex. That means the argument that is given is of two of complex types. This is the declaration of the friend function. Then the another function that is declared is show function. The return type is void, and the argument that is used in the complex. Right. Then there is a closing of the class, and there is a semicolon that is used. Then next is the definition of the friend function, that is a complex sum complex C1 and the complex C2 that is given. Then there is a next variable that is used, that is a C3, that is of complex type. Then C3 dot x equals to C1 dot x plus C2 dot y, that is C3 given, or the C3 object is taking the values from the C1 and the C2, that is a x value, that is a real part value, because we are assigned the real part into the x and the imaginary part into the y. So every x value, that is a real part value, is assigned to the, or is added up and it assigned to the C3. That is a real part of the C1 and the real part of the C2 are combined together and going into the C3. In the same way, C1 dot y and the C2 dot y, it is also added up, that is a C1 value of the y, that is a imaginary part, and the imaginary part of the C2 is added up and going into the C3 dot y, and there is a return C3, that is a returning of the C3. That is the return value of the C3, that is returning the value C3, because it is combining the feature, it is adding the features of the C1 and the C2. Then there is a next function, that is a void complex show function. This is the definition of the show function. This is print like as it is. like c dot x, whatever the values of c dot x, whatever the value that is given, then there is a plus j sign and there is a value of the c dot y. So whatever the value that is given or that is provided by the show function, that will displayed over here. Then there is a main function, that is a int main function, right? Then there are three we can say objects that is created, that is a capital A, capital B and the capital C. So there are three objects that is created. Then there is a clear screen for clearing the screen. Then a dot input, that is the input will be taken, that is the a dot input. Then b dot input, then c equals to sum ab, that is the c is given as a value and it is assigned the value as a sum, that is the ab. That is the input or the it will take the input value, that is the a dot input, and there are two values that is given, that is a 2.5 and the 4.5. In the same way b dot input, so whenever this input will be taken, the same values will be gone, or the same will be gone to the this one. Now the real part contains the 2.5 and the imaginary part contains the 4.5. So this is 2.5 is assigned to the real part and the imaginary part it is assigned to the 4.5. Then there is a c equals to sum ab. Then c out, a equals to a dot show. Now the show function will be used to display the output, that is the a dot show. Then there is a b dot show that is used. Then there is a c dot show. So this will print as it is, that is a dot show function, that means display in the output. Then there is a get ch for display the output on the screen, that is a get ch, and there is a return 0, right? Then there is a return 0, that means the value will be returned because it is of int function, right? So this is the program that shows how to return the objects. Now everyone, Larry and the Joseph, this program is clear to each and everyone? Yes students, tell me. Larry and the Joseph, this program is clear to you? You are Joseph? Okay, this is clear to you. Okay, now if I change the values, what will be the impact of this one? The values changes or the values remain fixed? Joseph, my question is to you. If I change the values will change or it remains fixed? Okay. So that means these values cannot fixed, right? It will change automatically whenever we move to the next place or whenever we change the values. Right, Joseph? Okay, all right, good. What about Larry? Larry, this program is clear to you? Okay, now if I change the value to a int, now what happened, Joseph? This will execute or not? Yes, Joseph, if I change the value to the int, that is float to the int, that is only 2, this will works or not? It works. Pardon? Now, if I execute this code, this will work as it is. Yeah, hello, Joseph. Hello. Yeah, hi, Joseph. Tell me. Yeah, it's working. Why? Because there is no criteria that int is taken as a int, float is taken as the float. As we studied in the this chapter in today's class only, whenever there is a built-in data type like int, char, float, it automatically change the data type. So it automatically change from the 2.2 to the 2 and the 4.4 into the 2. So we can give any value, anything that is given. So this is 2 plus j4 and 9.9 plus 2.3 and then the addition of these two. Now if I change from this one to again this one, again this one. Now what is the impact? This will work. 9 plus 2 is 11, 4 plus 2 is 6. That is a 11 plus j 6. Now, if I use as a dot 0 and if I use as a 4.0. Now, let's see what is the impact. Now, if I execute this code, this is not showing the 0 because 0 has no value. So, it will consider it as a simply a integer number, nothing else. So, this is 2942, not 4.0, not 2.0, right? So, this program is clear to each and every one. And if I exclude, hello, if I exclude this one, there will be error. What is the error? That is the class CLR should have a prototype getCH. That means CLR and the getCH are both defined in this one. That is a conio.h. Right. Now, if I compile, there is no error. That will work. Now, I have to save this file. By returning object, this is a returning object, then arrow will be used. So this is what we have covered is the how to return the object with the class. All right. So it's 5:47. So let's discuss what is the tomorrow's schedule. That is the inheritance chapter will be taken. In the tomorrow's class, I will be taking the theory of the inheritance as well as the practical part of the inheritance. That is in the first half, that is in the 1 hour, we will be taking the inheritance theory and the same practical, that is the practical of the inheritance also in the next half, because so that I will use, so that I will show your the same the theory as well as the practical. All right. So in the tomorrow's class, that is the important chapter, that is chapter number 8, inheritance. So I am taking the theory as well as the practical of the same chapter in the tomorrow's class. All right. So that's all for today's session. In the tomorrow's class, I'll be taking your next chapter, that is chapter number 8, inheritance. And tomorrow is the important class. Please attend, attend, attend. So thanks a lot everyone. Now, if there is any doubts, any queries, then you can ask from me. All right. Bye bye everyone. Yeah, Joseph. Hello. How are you? Yes, tell. Okay. Wood block. Okay. It works. No, no, no. It's okay. The main is that you have to understand the concept. The compiler is any compiler, no issues. But understand the concepts of the C language, C++ language. There is no matter of the compiler. Okay, all right. Any other doubts? Okay, so thanks a lot. Bye bye, everyone.